Hello and welcome to the Oracle Database World session, Never Down Applications with Oracle Maximum Availability Architecture. My name is Markus Michalewicz and I'm Vice President of Product Management for Oracle Database High Availability, Scalability, and MAA. And today, I'd like to talk about those components of MAA that provide never down applications. But as I will be talking about features that may only become available in future, please acknowledge the safe harbor statement. With that said, MAA was born against the background that any database solution out there has typically a high availability and or a disaster recovery solution. However, to make most efficient use of those high availability and disaster recovery solutions, you need guidance. And that is exactly what Oracle MAA provides for the Oracle database, a validated reference architecture set for high availability and disaster recovery. And the way we have done this some 20 years ago is we have taken customer insights and expert recommendations to create reference architecture starting with bronze, going over silver, gold to platinum, so that you can map your high availability and disaster recovery expectations against very defined configurations, including the production side and a replicated side. We provide this guidance on generic systems, on engineered systems, as well as in the cloud via the database cloud services DBCS, XRCS, and XRCC, as well as the autonomous database, all of which are based on MA principles and guidance. The areas that Oracle MA covers is continuous availability, data protection, active replication, and scale out. And for each component, for each feature and product within these areas, we provide guidance to ensure that your applications will be running smoothly and with the highest level of high availability and disaster recovery. However, today, I'd like to talk about the hidden gems of Oracle MA that provide never down applications. In order for me to do this, I've chosen three areas: continuous availability, active replication, and scale out. In the context of continuous availability, I will talk about application continuity and how it provides features and capabilities to ensure never down applications. For the area of active replication, I will do the same for Active Data Guard and SiteGuard. And last but not least, I'll be covering sharding for scale out, because we do have another session as part of Oracle Database World that covers Oracle Real Application Clusters, or RAC. So if you'd like to know how you can use RAC for scale out, then the other session may be the one that you're referring to. What we have learned as part of MAA some years ago is that protecting your applications from any interruption, however, isn't possible on the database level alone. We have provided as part of MAA database recovery and database protection for the longest time, and yet sometimes applications would have seen an error. And application continuity has been invented exactly to prevent that. It has been invented to protect your applications from seeing any interruption, whether it be for planned maintenance or unplanned outages. And the way application continuity does that is by preserving session state and replaying in-flight database transactions and or reads. Now, as you may know, if there is a failure on the database level and an in-flight transaction, so a transaction that wasn't committed yet and hasn't been preserved in the read logs and or the database files, it fails, the database server will roll back that transaction as if it never happened. And then normally the application would get an error message. Using application continuity, that error message will never reach the application, because application continuity will catch it on the way and replay the in-flight transaction, the transaction that hadn't been committed yet, in the destination failover or in the failover destination. So in other words, if you had the transaction fail in a RAC instance, it'll likely recover it or replay it, better to say, in the other RAC instance. Whereas if you had a data guard environment, it would have done the same in the standby site, which now had become the primary after the failure. That way, application continuity is unique to Oracle, but it's also available in two flavors for you to get the best out of it. The first flavor is application continuity, or AC itself. It's a highly customizable solution, but requires for you to use Oracle connection pools. Transparent application continuity, or short TAC, is the more convenient solution because it doesn't require Oracle connection pools, but it also makes certain decisions for you, so it automates certain decisions. That means, however, that you may have to look into your application how to best make use of TAC, and I have an example just in the next slide how you can do that. TAC and AC are available with Oracle Real Application Clusters and Active Data Guard, while in particular TAC is also available by default on the Oracle Autonomous Database, so that if your applications use the Oracle Autonomous Database, they will never see an interruption if the Autonomous Database ever goes down. With that said, some applications that you use with TAC may have coding practices that prevent safe replays. So in order for you to be able to determine the protection provided by TAC, you can use a tool called AC Check, or short ACCHK, AC Check Application Continuities Check, which you run in parallel to your application that you want to protect. Think about it this way. You run your application for a representative amount of time, and you run AC in parallel. Ideally, during that time, all the transactions in your application would have been captured, and therefore AC will report an output how each of the transactions that it caught would be tackled if there is ever a failure. I've shown here a little run, only a few minutes, to show you how this report could look and what you need to understand in order to work with your application to get the best out of TAC. Because remember, some applications may use coding practices that prevent replays and therefore may need to be adapted a little bit. Otherwise, TAC works just perfectly fine. In this little output here, you see the event type disable. And if you look at the last column on the very right, you see 2 times the term commit. What that basically means is that TAC has detected a transaction for which nothing need to be done because the transaction actually has successfully committed. So the transaction changes were persistent in the reader logs and all the data files already. So the transparent application continuity doesn't need to do anything for the transaction, even if there is a failure. However, sometimes you will find an entry such as disable and an error code behind it 41429. The error code means side effect detected, and what that means is that TAC has detected a transaction which it cannot fully control because there's a side effect within this transaction that is not controllable by TAC. A typical example, for example, would be using DBMS util and making a remote call, so a call outside of the database to a file or a URL-based web service, for example. If that call is made within a transaction, then it basically constitutes another transaction because you may have that DBMS util call a prerequisite or a part of the execution of that transaction. But as this call is made to a destination outside of the database, TAC could not control this transaction. Therefore, the embedding transaction, the one that runs within the database, would be disabled. We cannot safely replay it back if there is a failure. A simple solution to that would be perhaps capture the return, the result of the DBMS util call in a variable and use that variable in the transaction that runs within the Oracle database, and TAC may be fully aware of this transaction and can replay it back if it ever needs to. With that said, AC Check gives you a good report and gives you a good output so you can determine the protection provided by TAC as well as catch applications that use coding practices that prevent safe replays. But if you use it both together and you adapt your application, you will get a great continuous availability for your application, and any outages wouldn't show up on application level. Except, of course, if the infrastructure would fail, because application continuity works with the application, assuming that the application infrastructure is still running. Sometimes those infrastructures fail, and then the need arises to manage your whole production side with a push of a button. And the solution that Oracle offers in this context is Oracle SiteGuard. Oracle SiteGuard is a complete disaster recovery automation for complete site switchover or failover. It considers virtual machines as well as bare metal servers. It considers middleware, particularly Oracle middleware, but also others, and the Oracle database on generic systems or on Exadata engineered systems. It integrates with replication mechanisms such as DataGuard that synchronize primary and standby environments to protect critical data. So as you use DataGuard and you protect your middleware, you basically have your full production site covered. And if the site goes down, you can easily move the full stack to another destination that you set up in before. You can validate the recovery site with DR drills. So SiteGuard has a procedure that allows you to test either switchovers or failovers. You simulate the failovers, you test the switchovers, and you track the progress of which either on the command line or via Oracle Enterprise Manager. Now, as SiteGuard has been such a successful feature on premises for quite some time, we have recently introduced its complementary Oracle Cloud Infrastructure solution called Full Stack Disaster Recovery Service, or FSDRS. Now, when I say we have recently introduced, what we really introduced was a beta of which. So if you are interested in testing the FSDRS, please follow the blog link provided here to sign up for the beta and get to experience FSDRS, which is a fully managed disaster recovery as a service. FSDRS provides automated provisioning of infrastructure and service dependencies required for disaster recovery protection in a standby region. So if you have a set of virtual machines, bare metal compute, if so desirable, volume groups, and any of the DBCS autonomous database or XRCS services, what FSDRS will do is it will take the whole stack and should the site ever go down, make it available to you in another standby region. But more than that, it also takes care of the runtime management for Oracle Cloud Infrastructure-based deployments, and it provides a full stack switchover, failover, and DR drills on just a few clicks of a button via the OCI console. So it's very convenient for you to manage what otherwise would be a rather complicated DR operation. And one important component that FSDRS as well as SiteGuard manage is DataGuard. Now, DataGuard has been around for the longest time, and we have offered DataGuard as a disaster recovery solution. What is new, specifically in the context of Oracle's Converged database, is that now DataGuard allows you to manage workload on a per PDB basis. Or if I would put it in the context of DataGuard, you can manage DataGuard on a per workload basis. And that is particularly interesting if you look at what Oracle Converged database offers. You can run multiple workloads and or specialized data type based solutions in Oracle Converged database on ideally a per PDB level, meaning to say that your workloads are encapsulated in different PDBs. Now, if you do this, the different workloads, the different applications that represent that workload may have different requirements for high availability and particularly disaster recovery. And the traditional DataGuard would have taken care of those requirements in a way that it would have taken care of failing over the complete container database. So the whole container database with the PDBs within. That was the management level on which DataGuard in the traditional way had operated. With per PDB DataGuard, we allow you to manage a PDB within a container with DataGuard. How that looks is that you have basically two primary CDBs that are actively running workloads, and each of the CDBs can have different PDBs inside for which you can then choose to fail over or not on a per PDB basis using DataGuard. Disaster protection in this context is on a per PDB level. So is a potential transition from production to standby and vice versa with the DataGuard broker. So you don't have to worry to manage the whole CDB. You can choose which PDB should role transition or fail over should the need ever arise. We support traditional DataGuard features such as real-time apply and automatic get fetching from the source should one PDB fall behind. So you have full control over the individual workloads. And that is particularly interesting, as I said, when you run Oracle's Converged database. Because it allows you to basically operate on a per workload basis and thereby divide and conquer your workload. Now, speaking of divide and conquer, there is yet another solution that can be used to split up or to distribute very massive databases. And I'm talking about the database concept of sharding, which is basically a globally distributed architecture for massive databases. Now, sharding isn't a new concept, isn't a new architecture, and has been around for the longest time. What is new, especially for the Oracle databases, that we now offer an Oracle sharding solution, because we found that some applications need to scale globally and or prefer to divide massive databases into farms or into a farm of smaller databases. And these smaller databases then are known as shards. So instead of having one big sales database, you could have multiple separated and individual independent databases that represent Sales America, Sales Europe, and Sales Asia, for example, and yet have a logical view across all the sales as part of the sharded database. Oracle sharding thereby avoids scalability and availability issues for very large databases and uses native SQL to shard tables across up to 1,000 shards. And if you want to protect each of those shards, you can easily do this with a replica based on DataGuard or Golden Gate. The routing of SQL is based on a shard key, which is normal for sharded environments. And we support cross-shard queries as well as online addition and reorganization of shards in case you need to scale out or if you want to add additional regions or, for example, sales regions, as I've used here in this example. Thereby, sharding provides linear scalability and extreme availability, because you can easily add shards online to increase database size and throughput, and thereby benefit from online elasticity. That is a guarantee for linear scalability, because you can add a shard and it would automatically take care of the additional workload. In addition to that, sharding provides extreme availability, because the shared nothing hardware architecture enables it that a fault of one shard has no impact on any others. And remember, each shard can be replicated via DataGuard, so there's additional protection should a shard ever fail. And last but not least, you can make use of geographic distribution. For example, in my sales database, I have Sales Australia and Sales America been hosted in the cloud, symbolized by the cloud symbol, whereas Sales Europe needs to meet, so I assume, regulatory requirements. So I keep the data on premises, I keep the data in the country, and yet have a logical view over my sales database, which is a sharded database, and therefore has a logical view across all regions. Now, one of the most hard to fix database corruptions is actually a corruption of a database file itself. And even in sharded environments, data corruption often leads to hard to recover failures. Not so, however, if you use Oracle sharding, because Oracle sharding is based on the Oracle database, which can make use of Active DataGuard. And Active DataGuard has a feature to automatically recover from data corruption. And how that works is shown here on the right side of the slide in this picture, which basically has three components. The left bottom is the primary database to which I am connected. The right bottom is the standby. And in the window up top, we have a trail of the alert log of the primary database. And what I have done here in my example is I have connected to the primary database, and I will select the HR regions table. So I will select all the rows from the HR regions tables, which has 4 rows. And then I will check on the standby side, which has real-time query enabled, that I can also query the HR regions tables, and it does return, as you can see, 4 rows. Then I go back to the primary and I make an explicit DD that corrupts a block affecting the HR regions tables on the primary. It's a specific DD that does that. I flush the buffer cache to force the next read from disk, and then I select the same rows from HR regions. As you can see, my window on the top left, bottom left has not seen any error messages. What you may have not noticed yet is that in the upper window, where I trail the alert log of the primary database, the corruption was indeed detected, and Active DataGuard automatic recovery from data corruption was used to obtain a good copy of the corrupted block from the standby. So by using Active DataGuard and automatic recovery from data corruption, your application has not even seen the corruption because Oracle database fixed it underneath the covers. So the conclusion here is that Oracle database and the features in Oracle Database are better together. And together with MAA, we can really ensure never down applications. And by having shown you some examples, especially for application continuity and Active Data Guard, I hope you've seen how MAA can ensure never down applications with the right guidance and the right tools. If you would like to follow up on any of the technologies discussed today, please follow the links to the respective sites here, and also reference these additional Oracle Database World sessions, such as Simplify Application Development with Real Application Clusters and how to evolve your database applications entirely online.